Hi, I'm Alex Forsyth. I'm sorry I couldn't be with you today. I've been in 4-H for 10 years and I haven't missed judging a single time. However, this year, a dream came true for me. I get to be a paid intern at NASA working on electrical engineering. Unfortunately, that means I can't be with you today for judging. So, I'm going to share this video with you so I can tell you all about my project.
I created two components this year, a particle accelerator and a supercomputer. I decided on this project because I wanted to do something special for my last year in 4-H, to commemorate the many experiences and learning opportunities I have had through this program. The project itself is a supercomputer, or more specifically, a Beowulf cluster of 10 Raspberry Pis. The cluster monitors and controls a particle accelerator, which accelerates electrons from the back of the cathode ray tube and sends them quickly toward the front. The cluster has an operating system called Arch Linux, which is a very command-line oriented version of Linux. To load Arch Linux onto a Raspberry Pi, I had to use several SD card configuration programs on all 10 SD cards for each of the Pis. Once I had Arch Linux running on the Pis, I had to configure them so they could eventually work as a cluster. The first steps were to set a permanent or static IP address. I set each Pi's IP address sequentially, starting with port 10. Then I made passwords for the Pis that were all uniform, and began downloading programs I knew I would need. In order to program multiple Pis that did not yet have parallel processing capabilities, I used a program on my laptop called PuTTY to access 2 or more Pis by inputting their IP addresses. With PuTTY, I was able to download OpenMPI, which is the root of parallel processing on my cluster. Then I began generating SSH keys, which allow Pi 1 to access the other Pis. These keys had to be configured and placed in proper directories to work. I then downloaded Python 2 and 3 and their required programs so I could begin running my particle accelerator with the cluster. The particle accelerator is a cathode ray tube, and to start with, I had only a powerless tube. I built a circuit board with which to run the tube, and bought a power transformer, since the input power is about 230 volts. Once the accelerator was running, I had to configure it as well through the potentiometers, and afterwards through a waveform generator at Indiana Tech. With both the cluster and the accelerator working, it was time to connect them. I began outputting signals from the cluster to the accelerator, and after some adjustment, it worked! I plan to use this in the future for computations, running any program I may create that requires parallel processing, and as an educational tool. I learned a lot on this project. I learned how to get an operating system, like Arch Linux, on an SD card or USB. I learned how to use Arch Linux, what MPI was and how to use it, and so much more. Despite all of the challenges, this was a really fun project. After I returned from my NASA internship, I plan to expand the use of my Pi cluster. First, I plan to use it to benchmark the performance of various numbers of parallel processes, comparing the speed of 1 Pi versus 5 Pis, for example. As the County Science Ambassador, it has been my privilege to help children grasp engineering concepts. My cluster will help demonstrate the use and the speed differences of using parallel processing. Thank you very much for watching.